Oh Lord, I am going through hell trying to get this video recorded. I recorded another one and I had the measurements wrong and I couldn't correct that. It was too bad off. So I'm gonna do a quick drawing here. I just got the phone working. And what I'm doing is I'm extending the lines. So you got a ridge here, and then you got king common, you got two commons on this side, and then I don't know if I caught that. Then you're gonna have your hip running here, hip here. Now I just got these lines running through, so you see the symmetry that's going on. But what you got is, if I draw the square of this, would be 1.5 inches, 1.5, and then if I stick inside of that, what I'm basically doing there is I'm turning it. So if I take this square here and I turn it this way, I'm putting the diagonal measurement on top of the square. So how do? We got 1.5 by 1.5, and that should be, I believe, oh Lord, I can't remember what it is, but it's gonna be like 2 1/4 or something like that. We'll do it real fast. See how fast I can get my calculator up and running here. My phones have been just going so slow, it's unbelievable. But so we'll take, I don't know if that's even visible. So we'll take 1.5 times 1.5 plus 2.25. That gives us 4.5. I'll copy that, and let me put I gotta do a square root in here. Just cancel that out. Square root. Now paste in. Let me just get rid of that. Paste that 4.5 in. Put the square root in front of it, and it gives me 2.12. Okay, minus 2 times 16. I don't even care about this. Wait a minute. Hold up. 0.12 times 16. So it's 2. So it's an eighth. So it's 2 1/8. What you got on this distance right here is 2 1/8. And then on this, I don't even know if you caught any of that because I was holding it. But you got 1.5. So you got 1.5 here and 2 1/8. So if we're calculating this, the eighth and the half, it's all decimals. So I'm gonna keep that 0.12 in the calculator. And what I want to do is I want to subtract this dimension, and I'm looking through the phone, so it's gonna be a little slower. This dimension, these 2 points, here and here, that's this. I want to subtract the 1.5 from that, and I'm going to get what's left over. Now, what's left over is this little rise right here. That little triangle, the rise of that little triangle is what we want. All right? So, and what that transfers to is this. Oh, I'm doing something on this other phone, crazy over here. So that it translates to this, and these are equal. So the rise here is the run. It's, I guess, is it isosceles maybe? I don't know, equilateral. But we're going to know this distance right here. And that's, if you want to, okay, so I didn't clarify. Maybe in the description you'll catch it. But if we have, let me erase some of this stuff. You know, this most guys are not going to do it this way. And I could care less. It's all structural by the time it's said and done. But when you're doing smaller projects and you want it to, sometimes you work for a carpenter, you know, you work for a guy that's been doing it for a long time, and he just wants to come out there and look and see how you did it. And if it looks good, then you won't get that 3-hour talk about how he did it back 30 years ago. And he'll be like, wow, you looks good. But this is going up the rake. And this is, you know, this is going up. And this is going even more, you know, this is going up the rake the other way. So this is actually, if you're standing here, it's going down. And this one's going up the other side of the hip. 2 hips, broken hip right here. You know, this is actually not, these are not going to plane together. If I put my marker here and went this way, it's going to hit right here because this is higher. This side got to plane in with this board, which this one is going to plane on this side with it, but this has got to run all the way, you know, so it's not they're not planing together. But down, if you go down about 1 inch or 2, it's going to hit this one. So, but what the purpose of this is to be able to say, and we know this is set like 7/16 of an inch. It's common knowledge. You start adding these LVLs and things like that, it's going to change it. The thickness here starts, you know, you start getting a bigger ridge. You know, you got a ridge beam in there or something like that, and you put in a little 1.5 inch hips to it. It's going to change. So I'm just trying to give you, you know, and a lot of guys draw the plan view of this stuff down on the, you know, they'll find a piece of plywood and draw the plan view and all that. No problem. But math solves all these problems. You just have to visualize the geometry of it. And you start with what you know, and then you have to kind of it's like almost like algebra, but with triangles. You got to be able to solve for reducing the proportion or expanding the proportion of the triangle to get what you want. And if you could do that, you don't really need all this construction calculators and all that stuff, which I'm not saying don't use them, because they're definitely going to make you money 100%. But I do believe that we should know the theory of this stuff too, you know, because back in the day, framers, the guys that built, I mean, tremendous projects in Europe, all them churches you see, and they got all the arches and all this stuff. Those guys, I don't think they use calculators. They use a framing square and things like that. So if we want to take back, you know, some of the competency of our trade there, we got to start researching back into the, you know, how they used to do it back then, or we got to come up with our own way of doing it now, which don't include, you know, a microprocessor. So if you like that kind of thing, you like us really being able to recapture the trade like that, carpentry, framing, I encourage you to do your own research into this and see what you can come up with, and let me know.